In this video, we want to explain how we at DEA Deutsche Erdöl AG extract and treat natural gas today, using the latest technologies and applying extensive safety measures to protect people and the environment. Once a well has been completed and the steel liner has been cleaned, a production casing is inserted. Next, the outer liner is perforated. That is, holes are shot through the liner in the section passing through the gas-bearing rock, so that the gas can flow into the production casing and up to the surface. As a safety measure, downhole safety valves are installed inside the production well, at a depth of around 50 meters. During normal operation, these valves are kept open by hydraulic pressure. In an emergency, the spring-loaded valves close automatically. They can also be closed manually from the control station, however. On the surface, safety is ensured by the wellhead assembly, the so-called Christmas tree. It allows the natural gas to be extracted under controlled conditions. It is equipped with a series of guillotine dampers and shut-off valves. In an emergency, they close automatically and shut down the well. The facility is monitored around the clock from a permanently staffed control station. Sophisticated monitoring and process control systems protect the entire production facility through multiple levels of safeguards. Additional regular inspections carried out by field personnel also ensure that the operation runs smoothly. Once the natural gas has been brought to the surface, it needs to be treated to make it ready for consumption. It's first fed into the gas treatment plant, which is usually located right next to the wellhead. Here, water and other substances are separated out from the gas. In the first stage, the gas passes through a free water knockout separator, where the free associated substances such as water, sand and hydrocarbons are separated from the natural gas. In the next stage, the natural gas is cooled down to about 26 degrees centigrade, through a reduction in pressure and through air cooling. This causes most of the remaining water vapor to condense and precipitate in the pre-separator. In the downstream heat exchanger, the gas is cooled down even more, to approximately -30 degrees centigrade. At this stage, glycol is injected through a jet to prevent the formation of ice and hydrates. In the subsequent filtering stage, more residual water, as well as mercury and higher hydrocarbons, are separated out. Now that the treatment has been completed, the gas is fed into the long-distance gas distribution network. Special care is required in the transportation and disposal of the so-called reservoir water, a natural byproduct in the process of extracting gas from deep wells and bringing it to the surface. This highly saline water has been in contact with the natural gas in the reservoir for millions of years. As a result, some of the constituents of the natural gas, including benzene, have been dissolved in water due to the prevailing high temperature and high pressure. In a first stage, the hydrocarbons are separated from the water in sealed tanks using a gravity-based method. After further treatment, the water is either re-injected through wells and ends up in underground rock formations containing highly saline deep water, or it's taken to certified disposal operators by tankers. As a low CO2 energy source, natural gas will play an increasingly important role in the energy mix of the future. By providing over 20% of the domestic natural gas production, DEA is making a vital contribution towards maintaining a secure energy supply for consumers. In doing so, we engage in a close dialogue with the general public in an effort to improve our organizational structures and our processes on a continual basis.